This is Algebra 2, Lesson 8-4, Rational Expressions. A rational expression is the quotient of two polynomials. That means a polynomial divided by another polynomial. Simplest form is when a rational expression has no common divisors in the numerator or the denominator. For example, we have the problem x divided by x minus 1, and then that would be simplest form, or 2 over x squared plus 3. That would be its simplest form. Here we have x over x squared. That's not in the simplest form because the numerator has an x in common with the denominator that also has an x. And we have 1 over x divided by x plus 1, which is a complex fraction, which is definitely not in simplest form. And this last one, we have 2 parentheses x minus 3 divided by 3 parentheses x minus 3. The x minus 3s are in common, so that's not in simplest form either. You simplify a rational expression by dividing out the common factors in the numerator and the denominator. You can't cancel out like this. Please don't do this. Do not, do not, do not. You can't do this. That's impossible to do. So very wrong. That's so very wrong because there's a plus and minus sign between terms. The only way you can cancel something out is if there's only multiplication signs between the terms. So you have to factor the numerator and the denominator out to find the common divisors. A rational expression is any simplified form that must have the same denominator in order to be equivalent. Okay? For example, x squared minus x minus 6 divided by x squared plus x minus 2 factors to x minus 3 times x plus 2 on the top, x plus 2 times x minus 1 on the bottom. And then they would have the common factor of x plus 2. That could be canceled out because it's only multiplication. And you'd be left with x minus 3 over x minus 1. And you'd have to make sure you told people that x could not equal negative 2. Okay. In the example above, we must include negative 2 from the domain because negative 2 is not in the domain of the original problem. Note this restriction is not always evident in the simplified version, so if you want to make sure you tell people what their restrictions are, you have to look at the factored form before you simplify it to be able to tell people what their restrictions are. Okay, so just how do you simplify a rational expression? You will factor each polynomial in both the numerator and the denominator. You'll identify the domain restrictions by setting each polynomial in the denominator equal to 0 and solving for x, and then you'll cancel out the common factors to identify the excluding values. So here we go. We're going to simplify a rational expression. If we simplify 24x to the third y squared over negative 6x squared y to the third, there's many ways I can do this. I'm just going to show you the most reasonable way. I know that negative 6 will go into 24 negative 4 times. So I know my number is negative 4. I know that 2 of these x's will cancel with 2 of these x's and I'll be left with an x. I know that both of these y's will cancel with 2 of those y's and I'll be left with a y on the bottom. So I have negative 4x over y. That's the easiest way to do that. And I can cancel like that because there were no plus or minus signs between my terms. It was 24 times x to the third times y to the second. So I can cancel out above and below all I wanted. Letter B here, I cannot cancel out the x squareds and the x's because I've got plus signs and minus signs between them. So in order to cancel anything out to simplify, I must factor it. So I take the top of x squared plus 2x minus 8 and I would factor it. Remembering that you want to get a product of negative 8 and a sum of 2. So that would be, I do believe, x plus 4 times x minus 2 at the top. On the bottom, I need to factor out x squared minus 5x plus 6. So I need a product of 6 and a sum of negative 5. So that would be negative 3 and negative 2. So x minus 3, x minus 2. So before I cancel anything out, I'm going to look for my restrictions. My restrictions are wherever the denominator equals 0, and that would be where x was 3 and where x was 2. So I know my restrictions are that x cannot equal 3 and x cannot equal 2. I'll write those down right now. Now I will cancel out what's common. This x minus 2 cancels that x minus 2. So my final simplified answer is x plus 4 over x minus 3. And my restriction is x cannot equal 3 and x cannot equal 2. I have the simplified version, and I have stated my restrictions. Letter C here. I'm not a person who really likes things to be out of standard form. Standard form is in descending order of a variable. So I'm going to rewrite this so that it is in descending order of the variable. So we have this. I now have negative 4x minus 12 over to be plus 12, it should be plus 12, over x squared minus 9. Now I can factor it. The top I can take out a negative 4, and I'm left with x plus 3. The bottom, I can factor to x plus 3 times x minus 3. My common term is x plus 3, but first I must do my restrictions. My restrictions, x cannot equal positive or negative 3. So I know that x cannot equal plus or minus 3. I can leave it like that. I now know that these two things cancel. My final answer will be negative 4 over x minus 3. That's the simplified version, and my restriction is x cannot equal plus or minus 3. So all you're needing to do is factor it out. Cancel out common factors after you make sure you've listed your restrictions. You can use what you know about simplifying rational expressions when you multiply and divide them. So now we know about multiplying and dividing them. If I wanted to multiply a rational expression, what is the product from simplest form and stating your restrictions? Remember, this is just like multiplying fractions. If I wanted to multiply fractions, I would cross-cancel anything out that cross-cancels first to make it easier, because it's a whole lot easier to cross-cancel and then multiply than it is to multiply and have to find a common denominator and then reduce the fraction and hope I reduce the fraction correctly. So, what I'm going to do here, I'm going to reduce this by factoring out the numerators and denominators first. So in this particular case, x squared minus 3x plus 2 factors to x minus 2 times x minus 1. On the bottom is x plus 2. We're going to multiply this, factoring out x squared minus 36, that's x plus 6 times x minus 6. And the denominator, if I need to x squared plus 5x minus 6, that's going to be, I believe, x plus 6, x minus 1. So if I look at my denominator, my restrictions are that x cannot equal negative 2, negative 6, or positive 1. Those are my restrictions. So I know my restrictions are x cannot equal negative 2, x cannot equal negative 6, and x cannot equal positive 1. So those are my three restrictions. And now I'm going to simplify. I can cross-cancel this x minus 1 with this x minus 1, and this x plus 6 with this x plus 6. And I'm left with x minus 2 times x minus 6 on the top, all over x plus 2 on the bottom. And you don't have to multiply that together to make it in simplest form. It's in simplest form like this. If it asked us to add or subtract, then we would have to combine like terms and all that other stuff. But it didn't. It just asked us to simplify it, so that's the simplest form. This is our restriction, and we're done right here. Okay, so with multiplication, it's just a matter of cross-canceling first, and then multiplying, because it's a whole lot easier than multiplying first and then having to try to factor all that big huge giant mess. Now, if you remember when you divided fractions, if you divide a fraction, you're multiplying by the reciprocal. Same thing happens here. These are rational expressions. They're still fractions. They're just fractions with variables versus just fractions with numbers. So to divide this rational expression, we're going to multiply by the reciprocal of the divisor, just like you do when you divide rational numbers. So, if I have 6x minus 3x squared divided by 36 minus x squared, divided by the rational expression x cubed minus x squared minus 2x over x squared minus 5x minus 6. Here's a suggestion. You might want to flip it first and then factor it, or factor it first and then flip it. But whatever you do, don't try to factor it and flip it simultaneously. Something will get messed up. I personally flip mine first and then factor. So I'm going to rewrite this in descending order of the variable because I like things in standard form. So I have negative 3x squared plus 6x over negative x squared plus 36. I'm going to multiply this by x squared minus 5x minus 6 over x cubed minus x squared minus 2x. So I multiplied by the reciprocal now, so now I can factor it. So I turned it into a multiplication problem first. Now I can factor it, and once I've factored it, I can state my restrictions and then do all the fluffy math. So on the top, this is hard to factor unless I factor out a negative 1 first. In this case, on the top, I can factor out a negative 3x. Okay, so I'm going to end up with, if I factor out a negative 3x, I'm left with x minus 2. On the bottom, I'm just going to take out a negative 1, and then I'm going to left with x squared minus 36, which I know factors again, which I'll deal with in a minute. That factors to x plus 6 times x minus 6. Cross that out. I still have my negative 1, so I'll cross that out. So there's my new denominator. X squared minus 5x minus 6 factors out to, oh, let's see here, that would be x minus 6, x plus 1. And then x to the third minus x squared minus 2x. I can take an x out of that first. If I take an x out of that first, I'm going to have x. Then I'll be left with x squared minus x minus 2. I'll take an x out of it here. And that will factor to, let's see here, x minus 2, x plus 1. So there's my new denominator there. Okay. So, I probably should have done this. Let's do this down here so that you're not So we had this like with the x out, and I got x squared minus x minus 2, and then factor that again, and I got x minus 2, x plus 1, and that would be the place there. So now, when I cross cancel things, when I cancel out with common factors on it, I can try, well, I got to do my denominator first. I should do that first, because otherwise you might forget and cross it. If you cross it out too hard, you won't be able to see it. So x is not able to equal plus or minus 6, x cannot equal 2, and x cannot equal negative 1. So there's my restrictions. I can cross cancel out the x minus 2 and the x minus 2 there. I can cancel out the negative 1 with the negative 3 there, so now there's negatives gone. This x can cancel with that x. This x minus 6 can cancel with that x minus 6. Notice if you get really, really messy, you're not going to be able to read a thing. And this x plus 1 cancels with that x plus 1. Just use one line, make it neat and tidy. So, if you look across the top, I'm left with positive 3. Across the bottom, I'm left with x plus 6. So all of that simplified to 3 over x plus 6, with my restrictions of being x cannot equal positive negative 6, x cannot equal 2, x cannot equal negative 1, and I did forget one. I forgot this guy right here. I forgot that x can't equal 0 either. Because you have to set the entire denominator equal to 0, so x plus 6 equals 0, x minus 6 equals 0, x equals 0, x minus 2 equals 0, and x plus 1 equals 0. So there are 5 restrictions on this particular problem. So there's my simplification, there's my restrictions, and it's not really that complicated. It's just multiplication and division is multiplying by the reciprocal. So make sure you simplify first by factoring, and then cancel out what is common to both.